Hi Algebra 1, in lesson 5 here we're going to use our graphing calculators to find the exact line of best fit and the equation that goes along with it. Here we go. In graph 1, the solid line is a better line of best fit. The dotted line does split the data in half, but it's not showing the general trend of the data. In graph 2, the solid line again is the better line of best fit. The dotted line shows the trend, but it's not really going through the middle of the data. In graph 3, the dotted line is a better line of best fit. The blue line does cut the data in half, but the dotted line is going through the middle of the data better and showing the trend. In number 4, the dotted line is the better line of best fit here. It's going through the middle of the data and showing the trend the best. We are jumping ahead to activity 3, and for this you're going to want to probably do a split screen with Desmos and be ready to use your graphing calculator along with this data from your book. The first thing you're going to do in your graphing calculator is create a table of data. So use the plus button and choose table, and this is where you're going to put the x and y values from your table in your book. Once you've entered all of your data, adjust your window so you can see your data show up in there. And then the next thing we're going to do is write the formula that we need for a line of best fit. And you need a new line, and you're going to type in this exact thing, y1, and that's because up in your list up there, the y values are named y1. And then we have to find our squiggly line, and then we'll do mx1 because again in our data the x values are listed as x1, and then we'll just do plus b, and this should be familiar from y equals mx plus b. And when we are done with that, you'll see that our graph drew a perfect line of best fit for us, and now we have values for slope and y-intercept that we will use to create an equation. So remember, y equals mx plus b is what we always base our linear functions off of. And we're going to take our slope right here from the m, and I'm going to round it to 2 decimal places. So that's going to be 0.78. I still have x. And then for b, I'm going to put in the negative 9.4, round to 2 decimals, 4. So this is the equation of the line of best fit that the calculator made for us. In number 3, we're talking about what do the slope and y-intercept mean. So the slope is 0.78, and in our graph right here, we can see that as the temperature goes up, the pounds of ice cream sold goes up. But what the 0.78 means, as the temperature increases 0.78 degrees Celsius, goes up here, that's the rise, they will sell another 1 pound of ice cream, that's the run. And remember, if you write this as 0.78 over 1, then you'll see your rise over run a little bit more clearly. The y-intercept of negative 9.44, it's weird that it's in the negative. You were used to it being in the positive, but it means that at negative 9.44 degrees Celsius, they will sell 0 pounds of ice cream. And it kind of makes sense. If it's really cold, they probably won't. Number 4 is saying to use the line of best fit to predict the value when y is 10. So right here, I plugged in 10 for x, when x is 10. And when I evaluate that, I get negative 1.64 degrees Celsius. That means that when I sell 10 pounds of ice cream, it's only going to be negative 1.64 degrees Celsius outside. Is it a good estimate for the data? When I look back at my line on Desmos, not necessarily my sketch, I would see that it does seem to follow the trend of the data pretty well, so it seems to be a decent estimate. And there you have it, using Desmos to graph lines of best fit. The biggest thing to remember right here and to write this down is that this is what you type into Desmos after you have your data in a table to create your line of best fit.